Hello, everyone. Thank you for joining me. This is Dr. Grace Estrada for Ch8 Research Methods. Today, we're going to talk about Chapter 8, Quasi-experimental Research. So first of all, let's just recap what it is, what it means to have an experimental design. Remember that experimental designs are the only designs in which a researcher can draw causation, conclusions about causation. And this is what makes experimental designs the highest in terms of internal validity. So there are three components that we need to meet in order to say that we have an experiment. First is covariation of two variables. That means we have to see that systematically the values of two variables are changing together. So in other words, a change in one variable is predictably associated with a change in the second variable. The second component is temporal precedence. This is what really gives us that ability to establish causation. So with temporal precedence, that means that we actually have to see the change in one variable or cause the change in one variable before the second variable will change in value. And so tempo meaning time. So we use this time to establish that it's the directionality of that covariation that we noticed before. And then the third component that we need is elimination of plausible alternative explanations. And we achieve this through control and through random assignment. So you have these two variables that are changing systematically. We use manipulation of the independent variable to establish temporal precedence, and then we use control and random assignment to eliminate plausible alternative explanations. And these are the three components that make internal validity so high in experiments and also allow experiments to establish causation. This is why it's considered the gold standard in terms of research studies and research designs. So in a quasi-experimental design, we have most of those components. In other words, 2 out of 3. And because it's missing one characteristic of the experimental methods, we don't consider it an experiment. Often in quasi-experimental designs, we do have control of the independent variable. We will do that by either eliminating the extraneous environmental variables. In other words, we make sure that things like temperature, lighting, all those components are consistent in different conditions. And we also use random assignment. In this way, we make sure that there aren't any systematic differences in terms of our participants regarding who is in the control group and who is in the experimental group. In terms of the measurement of the dependent variable, we still establish covariation and temporal precedence. So with experimental design, what we usually are missing is random assignment. So oftentimes we want to have the control. We want to have the elimination of plausible alternative explanations. And we want to see that temporal precedence established. We often will revert to quasi-experimental designs in situations where it would not be ethical to randomly assign somebody to an experimental group. For example, let's say we're examining schizophrenia and the efficacy of cognitive behavioral therapy. Well, it would not be ethical for us to randomly, or even possible actually, for us to randomly assign somebody to be schizophrenic. This is not going to happen. So you would revert to a quasi-experimental design because the groups are already there. It could be people with schizophrenia and people without schizophrenia, and then seeing cognitive behavioral therapy. One way that you could do an experimental design with this would be to have all participants with schizophrenia, and then assign one to cognitive behavioral therapy group, and then another one to maybe psychoanalytic, and see which one is more effective. So you would, again, use quasi-experimental design when you want to have that control, when you want to have established temporal precedence, you want to eliminate plausible alternative explanations, but for some reason you cannot randomly assign people to the different groups. So two main types of quasi-experimental designs, very similar to experimental designs. We have within subjects, or what we call one group designs, and then we have non-equivalent groups. So the reason we call them non-equivalent groups is because we're being very conservative and we're saying we're not going to assume that one group, such as those who may have schizophrenia, are going to be exactly the same as those who do not have schizophrenia. So we just call them non-equivalent groups when we're looking at between subjects designs. In terms of within subjects designs, we have the one group post-test only design, one group pre-test post-test design, which will help us detect change in the dependent variable, and we have interrupted time series design. So let's take a look at these three. The one group post-test only design is very similar to the experimental design of post-test only. So here you have your participants, you introduce your independent variable, and then you measure your dependent variable. Notice that unlike a regular experiment, there is no random assignment into one group or another. You're simply looking at what happens to the dependent variable once the independent variable is introduced. With the one group pre-test post-test design, this has better internal validity than the post-test only design. So now you have your participants and you measure a baseline value for the dependent variable. Maybe we can say, levels of anxiety, for example. And then you have the independent variable is introduced, the treatment, and then you measure the dependent variable again. So remember, with one group, think of that as repeated measures. Then you have the interrupted time series design. This is a really powerful design, and among the three, this has the highest internal validity. So in interrupted time series, what you do is you spend some time, maybe, for example, in this picture, 7 weeks, measuring some kind of behavior. So in this example, we're looking at absences. So we're looking at how often employees are absent over 7 weeks. Then in the middle, that's why it's called interrupted time series, you introduce the intervention. And there you see it in the top, the treatment. And then for the same amount of time that you were measuring the behaviors, right? So we're 7 weeks before, after the intervention or the treatment is applied, you again measure behaviors for 7 weeks following. So you have periodic measures of the dependent variable beforehand. Then you implement the independent variable, and then you take periodic measurements of the dependent variable exactly the same amount of time as you did prior to the intervention, and you compare it. So in the top diagram, what you see is an effective treatment, because you can see that the number of absences after the intervention was introduced drops quite noticeably. On the other hand, on the bottom, that is an intervention that was not effective because their behaviors didn't change at all. So interrupted time series is wonderful because you get a lot of data points. Remember, with quantitative analysis, it's not necessarily many different participants, but it's many data points, and it helps you establish a trend. So among the three one group designs, the interrupted time series design is the most effective. So what are some threats to internal validity? Well, maybe we have some environmental variables that are confounding the effect of the intervention. For example, what if you're taking the study during the morning? In which case you'll see many, many more, late tardiness or absences maybe going on. And then in your post-intervention, something happens, researcher's not available, and just does the measures in the afternoon, something like that. So that would be an environmental variable that's changing it, not necessarily the intervention. There's also the issue of non-treatment participant change. So this is true for any kind of repeated measure study where it could be that it's just something that's happening over time, or something that's developing within the participant, maybe maturity. It could be hormonal differences that causes the change in behavior. So perhaps in that example where it's absences and over time, it could be that the person initially the people were being late because there was some kind of construction that was going on, or there was some, an epidemic like COVID that was happening. So these are non-treatment participant changes, or maturity. Maybe it's something that they're going through sleep apnea or some sort of physical problem That could be accounting for the changes. Measurement errors, so that could be perhaps they're recording their participants, their employees as they come in. And what happens if the camera glitches, or it's a network error that makes it seem like they're late, but they're not really late, those kind of ideas. Order effects always becomes an issue if the time between the treatments, like maybe your baseline and your post-intervention measurement, if that has an effect on the participants, that it's not actually the intervention itself, but something just, going through it repeated times that causes the improvement. Expectancy effects occur when the experimenter knows, obviously, what their hypothesis is, and because they're really interested in making in ensuring that the hypothesis is supported, that they are interpreting ambiguous actions or behaviors in a way that supports the hypothesis. So that's the experimenter expectancy effect. The participant effects, also known as reactivity, is that the participants are aware that they're part of a study, and because of that awareness, they change their behavior. So it's not because of the intervention, but it's actually the knowledge that they're part of the study that causes their change. So anything that really deviates from the authenticity of how participants are behaving is a threat to internal validity. So confounding from time-related variables. Well, when we talk about this, a time-related variable means that it's not connected to the experience of the participant from the treatment condition, right? So this is something that's going on. Non-participant change, there are two types. Maturation, as I mentioned, that's something within the participant's physiology or psychology that's causing the change. And then history has to do with external events that are impacting the participants. So the COVID epidemic is an example of history change. Maturation would be, maybe if the participants are going through some kind of physiological change, maybe it's women and they're going through menopause and it's causing hormonal changes, and that's what's impacting it rather than the intervention. So that's what we mean by non-treatment participant change. In terms of measurement errors, instrumentation means that maybe it's the measuring instrument that is problematic and causing changes in the dependent variable. So again, for example, if they're basing the behaviors or knowledge of the behaviors on recordings, and there are, Wi-Fi issues, or something goes wrong with the recording instrument, that's an instrumentation error, and that is going to be a threat to internal validity. And then regression to the mean is a statistical event that happens. That means the extreme scores that people experience over time will start to move towards what the average is. So that's what we mean by regression. So mean meaning the average, and regression is that either very extreme high scores will start to go down, or very extreme low scores will start to increase. Either way, the extreme scores over time eventually find their way back to the average. And that's not because of the intervention, but really just something that naturally happens organically. Other effects, order effects, again, we talked about this with repeated measures design. So fatigue is when participants, do more poorly as the repeated measures occur, and that's because they're bored or they're tired, they're sleepy. Fatigue happens when you have a decrement in performance. Practice, on the other hand, happens when you can know that that's happening because there's improvement in the performance. And it's not because of the intervention, it's because they remember what the questions were or things like that. Another carryover effect is like the contrast effect, where it's the perception that the participants have, it changes because of the testing. So that's what we mean by a contrast effect. Expectancy effects, as I mentioned before, experimenter expectancy effect is simply the experimenters interpreting ambiguous events as supporting their hypothesis. So that could be problematic. One way that you can reduce that is through a blind study where the person analyzing the data is not knowledgeable about what the hypothesis is or what group people are in. And then, as I mentioned before, reactivity means that people are behaving in a way that is not authentic, and it's because they know that they are in a study. So demand characteristics are when the participants think that they know the hypothesis and will respond in a way that they believe will support the hypothesis for the researcher. So they think they're trying to be helpful, in other words, right? And then social desirability is when the participants believe that somehow their responses will be traced back to them, and they want to appear their answer in a way that they think people will like or admire them for the answers. Anything, again, that takes participants' reactions and behaviors and moves it from being authentic to something that's contrived is a threat to internal validity. Okay, let's talk about non-equivalent group designs now. So in a quasi-experimental study, as I mentioned, oftentimes the missing element is random assignment. So when you don't have random assignment, we're going to say that the groups are not equivalent, right? So it's just, even if you try to make them as equivalent as possible, the assumption will be that because random assignment was missing, these are non-equivalent groups. So we have post-test only non-equivalent groups design, pre-test, post-test non-equivalent groups design, interrupted time series design with non-equivalent groups, and pre-test, post-test design with switching replication. Buckle up. Okay, so we're gonna have to know the differences among these. Oh, and the last one, switching replication with treatment removal. I'll talk about ways to distinguish from these different types. Right, so non-equivalent post-test only design. Remember, there's no random assignment. We have two groups. We introduce the independent variable to the experimental group. We do not introduce anything to the control group unless you're doing some sort of placebo. And then we measure the dependent variable. So very straightforward. You know, as I mentioned, maybe it has to do with smoking, for example. So the experimental group would be people who smoke, the control group would be people who don't smoke. Maybe there's some kind of intervention to reduce the smoking, and that's what you measure. All right, non-equivalent pre-test, post-test only design. We've seen this before where you have the participants, you take baseline dependent variable values. Then for the experimental group, you introduce the independent variable. In other words, for this example, they get exercise. And in the control group, they get no exercise. And then you have the post-test dependent variable. Maybe you measure stress levels or something like that, where the experimental group gets exercise, then you see if their stress levels are the same, and the control group no exercise, and you see how their stress levels are. And of course, in this situation, you want to see that the group that got the intervention, the experimental group, indicates notable improvement as compared to the control group. Interrupted time series design with non-equivalent groups. So this is exactly the same as the interrupted time series design that I mentioned, but in this case, we are doing it with the two different groups. So you have the two non-equivalent groups. For the same period of time for both, you are going to record and examine their behaviors. Again, this is kind of absences, right? And then you implement the independent variable to the treatment group. And then you watch to see, was there any change between the two groups? What you want to see is that the behaviors of the ones who were in the treatment group improves, and the ones who were not in the treatment group, that you're expecting not to see any change at all. So again, interrupted time series design is really nice because you're collecting many different data points over quite an extended time. But again, because it is over an extended period of time, that's more costly than it would be if it were just one time. Pre-test, post-test design with switching replication. So here, let's walk through this carefully, right? You have your participants. Again, you have non-equivalent groups. So you measure a baseline for the dependent variable. Let's say it's anxiety. And maybe it's some sort of maybe genetic form of anxiety, or maybe we can say it's bipolar. Maybe people are being bipolar. The experimental group, they get exercise. The control group, no exercise. Then you measure the dependent variable again, right? So you take a baseline, introduce the independent variable, and take the reading after they've had the intervention. Then the switching replication comes in, is that the control group that did not receive the intervention, second time around, they do receive the intervention. And so now in this, you're going to see both the control group and the experimental group have the intervention of exercise, and then you measure the post-test dependent variable. What you're expecting to see is that the experimental group, because they keep having the intervention, that their values will still be really good. What you're looking for is that the control group values from the second time that they're measured, from the and then the third time that they're measured, that there's going to be a change between when they got the intervention and when they did not have it. So it's stronger because what you're looking for is, again, the more data points you have, and because it is the same group of people, you're looking for change from one time to another. So for the experimental group, you want to see a change between time 1 and time 2, because that's when the intervention was introduced. For the group that was the control group, you expect to see a change between time 2 and time 3, because that's when they were exposed to the intervention. Switching replication with treatment removal design. So in this one, very similar to the last one, right? You have your participants, you get their baseline measure, introduce the independent variable to the experimental group, nothing to the control group. You take measures the second time and you expect to see improvement in the experimental group and no change in the control group. And here's the treatment removal part. Now you're going to take away that therapy, the exercise from the experimental group, and you're going to introduce exercise to the control group. And that's the switching replication and treatment removal. In the previous one, you did not remove treatment from anyone. You just added treatment to the control group. In this design, you are removing the treatment from the experimental group and adding treatment to the control group. And then you take measures again. So what you want to see here, what the pattern you're looking for, is that between time 1 and time 2, the baseline measure to time 2, you expect to see improvement in the experimental group and no change in the control group. Then between time 2 and time 3, you expect to see that the improvement will decrease, or how they behave will decrease in the experimental group because you took away the intervention. And now you expect to see improvement in the control group because now they have received the intervention. So switching replication, eventually everybody gets the intervention. Switching replication with treatment removal, you're taking away the treatment from the experimental group and you're adding treatment to the control group. So make sure you understand the difference between those. So some threats to internal validity. The big threat is that there's no random assignment, right? Groups are formed, but circumstances do not permit random assignment. So what you could have are differential effects that occur because there was no random assignment, because there are assumed to be systematic differences between the control group and the experimental group. So first of all, there could be assignment bias where the differences, are set up so that your hypothesis is supported as a researcher. And then we have something called selection interactions, meaning, those other threats to internal validity that we talked about in terms of instrumentation error or maturity, non-treatment change, those things that in combination with the selection interaction makes it much more challenging to have really high internal validity in these studies. So just to summarize, okay, quasi-experimental research and threats to internal validity. Well, the environmental variables, so such as things like, are you testing them in the morning versus afternoon or evening? The experimenter expectancy effects, where people are human and researchers are, interpreting ambiguous results as somehow supporting their hypothesis. We have measurement errors, two of them instrumentation, having to do with things like recording devices going wrong, or maybe even a scale or measure, whatever scale you're using, the batteries dying, those kind of things. Those are all instrumentation errors. Regression to the mean is a statistical organic difference that happens where extreme scores move towards the average over time. We have non-treatment participant change. Maturation has to do with something physical, physiological, or biological in the person, such as, going through hormonal differences. And then history has to do with the external event in the environment that could possibly change what's happening with the participants, such as the COVID pandemic. We have order effects when we're talking about, repeated measures or one group designs. So fatigue is when they do worse over time, practice is when they do better over time, and carryover contrast is just being in a study changes how they respond. We have systematic group differences, especially with a non-equivalent group situation. So with differential effects, we're talking about because there is no random assignment, that there are systematic differences between the groups, and that could actually be what is more impactful than the intervention. So selection bias is that, since we don't use the random assignment, that the researchers are deliberately making kind of like setting it up so that there's more chance of their hypothesis being supported. And then, as I mentioned before, there's that selection interaction. So these other threats to internal validity, the environmental variables, the experimenter effects, measurement errors, all those things become even more magnified when you have systematic differences between the groups. Attrition can also happen. Those who stay in the study may be systematically different than those who decide to leave. And then we have reactivity, where knowing that people are in a study will change how they behave. So demand characteristics would be the participants wanting to behave in a way that supports what they think the hypothesis is. And then social desirability is when participants react in a way that they believe will make them look better to other people. So types of validity. It is the same. We have to do the big four in all the different research designs. So with construct validity, we want to make sure we're addressing the different aspects that are involved in the psychological construct. We also want to make sure our operational definitions are sound. Oftentimes, this means that we're going to look at previous studies and see how established researchers have already defined it, or the different dimensions that need to be included. So this would be part of your literature review. Internal validity, as I mentioned before, that has to do with the confidence a researcher has that it was the manipulation of the independent variable that caused a change in the dependent variable. So again, we have to meet those components where we want to eliminate the plausible alternative explanations through control. We don't have random assignment, right? We want to also establish the temporal precedence by the manipulation of the independent variable and see that there is covariation in at least two of the variables we're looking at. External validity has to do with the generalization of the results. So construct validity is the psychological construct that we're investigating actually accurately being represented in this study? Internal validity has to do with the structure, the integrity of the study, how well we can actually say it's because of the manipulation of the independent variable that the dependent variable changed. External validity has to do with the results. We want to be able to say that the it did not just apply to this sample, but we believe it will apply to other populations and other contexts. And then we have statistical validity. We want to show that the analysis that we conduct is appropriate for our research goal, for the number of participants we have, all of those components. So pros and cons of quasi-experimental research. Usually they're less expensive than experiments. We can usually have them go through more quickly. We can include, this is a big one, we can include participants often excluded in experiments. So we again rely on quasi-experimental research when it is not ethical or not possible to randomly assign people into these conditions. So we often use it to assess interventions in medical treatments because of that. We're deliberately using this where we want to have control and we want to have manipulation of the independent variable, but because of ethical reasons, we cannot do random assignment. And definitely has much more internal validity than non-experimental studies because we are trying to establish control. We are trying to eliminate alternative explanations, and we are intentionally manipulating the independent variable. So because there is, that idea that we're working with groups that naturally exist, that potentially there is greater external validity than in experimental designs. And finally, the disadvantage is that there are more threats to internal validity than experiments because of that lack of random assignment. So that is the end of our discussion on quasi-experimental design. Thank you so much for joining me.